Hi everyone, I'm Haowei from Google. Today I'm presenting a talk on Introduction to LLVM-IFS and its usages in Fuchsia build system. The talk will be divided into following sections. In the beginning, I will explain what is LLVM-IFS and the motivation behind developing it. In the next section, I will compare LLVM-IFS with existing similar tools. In the last two sections, I will present how we integrate the LLVM-IFS in the Fuchsia build system and present some future directions for this tool. So what is the LLVM-IFS? The IFS actually stands for InterFaceStub, which is the text representation of ELF shared objects. So as the name suggests, one of the primary features of this tool is to generate human-readable text representation of an ELF shared object, which is an IFS file. And another feature is to generate linkable ELF shared object stub from either the ELF shared objects or the text-based IFS. And the last feature would be generate IFS directly from source files. The motivation behind this tool is relatively simple. First of all, the shared object stubbing is very helpful. It reduces the size of link time owning binaries, so it can reduce the sizes of distributed packages like the SDKs. Another aspect is that we are seeing frequent changes in the link time ABIs. This type of breaking changes breaks the build, and they are extremely hard to spot during the code review process. If we can have a human-readable representation of the ABI, that will help to avoid this type of issues. Here is an illustration of what LLVM-IFS can generate. The ELF shared object used in this example is the international complements for Unicode library. Even after stripping off the debug symbols, the library size is still relative at 3.8 megabytes, which is not small. However, we don't need all the 19 sections for linking a dynamic linked ELF that depends on this library. With the LLVM-IFS, the library can be further stripped to have only 4 sections that contains necessary metadata and dynamic symbols. The binary stub is still compatible with linkers, but the size have been reduced to only around 670 kilobytes, which is less than 20% of the original stripped shared object. That's a lot of size improvement. The text representation of the same ELF shared object can be seen here. It uses a YAML format that is containing everything that is needed to generate a linkable ELF stub. In case there is ABI changes, the content of this file will be changed as well. So we can use regular diff tool on this file to detect ABI changes. Before LLVM-IFS was developed, there are already several projects that share the similar ideas. The Microsoft import libraries and Apple TAPI projects are the two of them. The import library is a staff version of the dynamic linked library that they were only used during the link time by the Microsoft linker. However, the staff file is not human-readable, so it is not very useful to detect ABI changes. The TAPI from Apple, on the other hand, generates human-readable text stub directly from source file and is directly supported by the linker. However, they are only available on the Apple platform, so it is not very useful in the ELF. LLVM-IFS, on the other hand, can generate both binary stub, and they are compatible with linkers and like LD or LLD, and they can also generate text stubs for human. It also supports ELF, which is very useful for us. The current LLVM-IFS is actually merged from 2 different tools. Google developed the LLVM ELF ABI a while ago for generating text-based and binary-based ABI stuff from ELF's binary, while engineers from Facebook developed the LLVM-IFS, which generate text and binary-based stuff from the source code. And both of these tools share a very similar text format, and we think that they were better to be merged to avoid reinventing the wheels. So how do we use the LLVM-IFS in Fuchsia? Currently, we have 2 main use cases. One is to avoid unnecessary relinking in incremental build. To do that, for each shared object's target in the Fuchsia build, we will generate a regular shared object file and an text-based IFS file. The timestamp of the IFS file will not be changed if the content is not updated during the incremental build. Of course, with a special if not changed flag. And if in a following incremental build, the implementation of the shared object is changed, but the IFS file remains the same, the binary target depends on this shared object file will skip relinking as the link time ABI is not changed. This is very helpful during the pandemic because developers may not have the access to the powerful workstation in their offices. And this helps to reduce the turnaround time for small local changes. Another use case is to detect ABI changes in the code review. For each crucial system libraries targets in the Fuchsia, like the library for the syscalls, we generate an IFS file and check it into the Fuchsia source tree as golden files. When Fuchsia is being built, each IFS file will be generated again from freshly built libraries, and they will be compared with the golden files. If there is a difference, the build system will report an error as an ABI change is detected and ask the developer to regenerate the IFS file manually and replace the golden file in the source tree. When developer uploads the local changes for code review, which will include the changes to the IFS golden files, the code reviewer will be aware that ABI have changed. This is helpful to prevent accidental ABI changes and help to coordinate the ABI breaking changes across multiple projects that depends on the Fuchsia. Another benefit from this approach is that the ELF targets that depends on these system libraries can be built and linked early by using the stub generated from the golden files instead of waiting for the actual library to be built by the build system. This helps to increase the build parallelism and reduce the build time. So that wraps up. There are still a few things that we hope to add to the LLVM-IFS. One thing is to support ABI signature changes monitoring through the libabigail. And this would be helpful to monitor ABI breaking changes, but this part would need a lot of work. Another aspect is that the LLVM-IFS is currently still only supported for ELF format. So if a product that needs support on Windows or Macs, these are currently not available. So there will be a good add-on to this tool in the future. Yeah, that's all. Thank you.